We should be good at spotting these kind of questions. We've got a line is given to us with one equation. We've got a curve with another equation. Question talks about intersections. And importantly, it says they intersect at two distinct points. Okay, so if a line and a quadratic intersect at two distinct points, we're going to be thinking about discriminant equals 0. Now, we need to do a bit of work before we get there. So let's just start our algebra off by referring to these two equations. So we've got the straight line, which we're going to call equation 1, and we've got the curve, which we're going to call equation 2. Okay. We need to start looking for intersections, so we need to solve these as simultaneous equations. So we're going to substitute, I'm going to substitute 2 into 1, because it's already been rearranged to y equals. So I'm going to have 3x minus 2. So instead of y, I'm now putting 2x squared minus 5, and that equals k. Let's expand, simplify. 3x minus 4x squared plus 10 equals k. And I'm going to move everything to the left, just so I've got positive x squared. So I'm going to have 4x squared, sorry, move everything to the right. 4x squared minus 3x. The k is positive, but the 10 is negative. And this quadratic equals 0. So this is a quadratic equation in x. It will hopefully have 2 roots. That's what the question wants. But it only has 2 roots if its discriminant is positive. So if b squared minus 4ac is positive. So let's quickly summarize what a, b, and c are. From our quadratic, a is 4, b is negative 3, and c is that numerical expression at the end, k minus 10. So therefore, we want b squared minus 4 times a times c to be greater than 0. Okay, so this is a little inequality. When we simplify it, minus 3 squared is 9, minus 16k, minus 16 times minus 10 is positive 160. We want that to be greater than 0. So we've got 169 on the left. Let's move the k, 16k on the right. 169 over 16 greater than k. Looks a little bit strange. Just write it the other way around. K is less than 169 over 16. Not the nicest numbers, but we're done.